Okay guys, so this is our Alka-Seltzer Lab dealing with weathering, looking at physical and chemical weathering. The first part of this, what we're going to do is we're going to be taking a look at dissolving a whole versus crushed Alka-Seltzer. Okay, we have two beakers. Each beaker has the same amount of water. Each has about 250 milliliters of water, and the temperature for each one is 10 degrees Celsius. So same amount of water, same temperature. The only difference is that one is whole and one is going to be crushed. Now we have to get a time for this. Now on the front page of your lab, you're going to be writing down the time. I will let you know when we start and when we finish, and then you guys can take a look at the time that it took for the whole. So the first one going in is the whole, and what I'm going to do, I'm going to drop it in and start it at the same time. You ready? 1, 2, 3, go.
Mr. Clark, this is pretty crazy exciting. Now, I guess the big question here would be, where is it actually reacting with the water? All right, so guys, where is it reacting with the water? Is it reacting on the inside with the water? It's not reacting on the inside. It's only reacting on the, okay, who said it? Surface. There you go. All right, so fizzing away. You guys are on the edge of your seat. Yeah, it's already in 40 seconds. Still fizzing. Mr. Clark, I'm just beyond myself with excitement.
I know, it's still going.
Can you believe we get paid for doing this, Mr. Clark? This is what a great job. Yeah, here we go. Oh, still fizzing up a storm. By the way, you use Alka-Seltzer for stomach upset. That's what these little tablets are for. But notice, it's a whole tablet. It's only going to react right at the surface. How are we doing, Mr. Clark?
We're still going. We're at about 1 minute and 15 seconds for the whole tablet in the 10 degrees Celsius water. And it is taking a little while to do this.
Well, if I had stomach upset, I would really be looking forward to it getting done.
And we're getting close.
Right. Still fizzing, but not much left.
We're almost there.
Okay, Mr. Clark's gonna call it. Notice the time.
And I would say we are done now.
All right. Look at that. Finished fizzing at about 2 minutes and 5 seconds. Way to go, Mr. Clark.
So 2 minutes and 5 seconds. So if you look over here, all right, for the whole, we have 2 minutes and 5 seconds.
What now, Mr. Clark?
Okay, so now the next step is, again, in the same temperature and the same amount of water, we are going to put the crushed Alka-Seltzer in, and we are going to time that.
So wait, are we saying the only difference is that this is crushed, everything else is exactly the same?
Only difference. The only difference is that it's crushed, very small particle sizes. Okay, so that's something to take a look at. Again, very small particle sizes, and we're going to dump that in, and as soon as it goes in, I'm going to hit start. Ready? 1, 2, 3, start.
So the only thing we've changed is the particle size. Now, where does this stuff react? It's on the surface, and because Mr. Clark has crushed it pretty thoroughly, the surface is everywhere. Wow, that's reacting pretty fast. Whoa, Mr. Clark is the professional here. He's going to call it.
I'm saying that that's just about done right there. Okay,
Whoa.
And that's 25
seconds, and that puppy is all done. That's a big difference, Mr. Clark.
25 seconds. Okay, so now you guys, on this portion of it, the front page, you have the time for the whole, you have the time for the crust, and you can have your own observations in each one of those boxes there. Okay, so now we're going to move on to the second part, that we have the hot water. Okay, so each one of these, the volume is 250 milliliters. 250 milliliters, 250 milliliters. The temperature of the cold is going to be 10 degrees Celsius, okay? And the temperature of the hot is going to be 65 degrees Celsius.
Wow.
Okay? And for this experiment, okay, so the only difference between what we're using here is going to be the cold versus the hot. We have the whole, okay, same amount of water, cold, hot.
Hey,
Okay?
Mr. Clark, can I point out something? I think we're noticing a certain thing about this. We're only changing one thing at a time in each experiment. That kind of shows that it can only be one thing causing it.
Yes.
Right?
Yep.
In the first one, it was the amount of surface area, and in the second one, it's the temperature of the water. Huh.
So
Good
we're
to
going to
know.
take a look. I'm going to do the hot one first since we already kind of did the cold one. It should come out similar. But I'm going
Wait,
to...
Mr. Clark, I've got an idea.
Yeah.
Want to be radical?
Yes.
Let's do them both at the same time.
All right, we'll
Let's
do 'em-
make it a race.
We'll do them both at the same time.
Get out. Oh,
Okay.
boy. All right, I'm ready to hit
So
start.
you ready? I'm going to drop it on 1, 2, 3, go.
Boom.
Holy cow, look at that hot
Whoa.
one.
Look at, not much. Much. That's crazy. That's crazy. Holy cow.
And that hot one is just about done. And it's done. And we're at about 17 seconds.
Whoa. That's
17
crazy.
seconds for the hot. And we're moving slow but surely. With the cold. And what a difference between the temperatures.
Wow. So we also get a chance to check previous stuff because we had water that was about the same temperature over there, and it should take about the same amount of time, right?
We're hoping.
Ballpark, somewhere around 2 minutes. All right, so yeah, it looks like it's doing about the same thing that it did before.
And make sure you're writing down some of your observations. You always have to write down observations with your experiments.
Okay, what kind of things are you noticing? Any little funny things that you notice about any of the experiments are always really good to write down. Sometimes those little funny things start whole new sciences. So as science observers, it's really important to pay attention, especially if you see something that doesn't quite make sense. That's sometimes the coolest thing of all.
Okay, guys, just double check this. I had this in the wrong spot really quick. The hot water, 250 milliliters, 65 degrees Celsius. It took 17 seconds. The cold water is 250 milliliters. Temperature was 10 degrees Celsius, and we're still working on that time. We're coming up, and it's going to be pretty close again.
It's going to be pretty close. Okay, Mr. Clark, you call it. We're focused in on the time.
And we're close. It's right about there. Done.
Bam. Whoa, Mr. Clark.
What is that?
What did we get for the first one at that temperature?
205.
We got 205. We got 205 again, Mr. Clark.
Did we get? Yeah, we got 205 exactly again.
Let's hear it for science.
That's good, guys.
Woo.
All right, so now you guys have all the data that you need in order to finish up this lab. Okay? If you have any questions, you let either I or Mr. Johansson know, and we're good to go. Thank you, guys. Have a good day.
Woohoo! Thank you, Mr. Clark.